NASA's latest mission is underway. OSIRIS-REx is the agency's first attempt at intercepting and touching down on an asteroid. No ordinary asteroid either. Bennu is its name. Orbiting the Sun very closely to Earth's orbit, it has been deemed a possible impact threat in the coming centuries. NASA intends to take a sample of the asteroid and return it to Earth for further study, and possibly help form plans to redirect Bennu. To match the orbit, OSIRIS-REx made a very close swing by the Earth a year after launch. It passed by the South Pole to change its orbital inclination several degrees to match that of Bennu. Once matching orbits, OSIRIS-REx must perform a series of braking maneuvers to match velocity and enter an orbit around the asteroid. After mapping and studying the body, OSIRIS-REx will drop down to the surface and collect a sample of material. With some clever robotics, the sample return capsule will be delivered back to Earth.
Well, the thing that is so intriguing to me about asteroids is that they really are time capsules. They actually are samples of what the solar system was like billions of years ago. Asteroids are small bodies that never got made into something big like a planet. So anything that got made into a planet got melted down, got changed. There were lots of things that went on. Asteroids are pristine. Nothing really altered them for billions of years. So when you go out and you take a sample of an asteroid, you have in your hands a real sample of what the solar system was like billions of years ago. What were the conditions? What was the chemistry like? What can you learn about the formation of our own planet and ourselves by looking at what the solar system was like billions of years ago? And this sample is incredibly scientifically important. I think that people will be studying it for generations to come.
The Juno space vehicle was launched in August 2011. In 2012, at perihelion, the craft performed some maneuvers out beyond Mars orbit and arched back towards Earth for a kick in speed and direction. In October 2013, it flew by Earth a mere 500 kilometers from the surface. This slingshot sent it on a 3-year journey directly towards an interception with Jupiter.
Jupiter orbit insertion is probably one of the most important things in the entire mission, and it's because that changes us from being in orbit around the Sun to being captured in orbit around Jupiter. And if you're not in orbit around Jupiter, you can't do the science we want to do. And what we're learning now is even in other solar systems, they don't always all have a monster like Jupiter. And many people think, boy, you almost need a Jupiter to have an Earth maybe. Jupiter played a big, important role. But its environment, everything about it is extreme. It's a planet on steroids, right? It is the most extreme in every way it can be. So it has the strongest magnetic field, the strongest gravity field. It has the most harsh radiation. It's spinning super fast. I mean, everything about it is this extreme environment.
The Juno mission is unique because it's the first time that we've ever gone in a polar orbit, which goes from pole to pole, over the North Pole, through periapsis, and under the South Pole. All the other missions we've done and all the observations we made from Earth were made from the equator. And you don't see the poles very well if you're sitting on the equator. Yeah, so this is the first time we get the first clear, unobstructed view of what the aurora looks like and what the polar phenomena looks like And at the same time, we're flying through the magnetosphere right above the aurora, so we can sample in situ the charged particles that are precipitating down magnetic field lines, the guys that are exciting the emissions that we see. This is the first time we've ever been able to do that.